Please go ahead.
Okay, thank you for the time that I can present here. First of all, I want to say thanks to the committee that giving me the opportunity to share our part of our research here. Here I will present the part of my research entitled "The Climate Change Detection Using Bayesian Change Point Method and Empirical Orthogonal Function for Improving the Traditional Cropping Calendar in the Daerah Istimewa Yogyakarta Province of Indonesia." Here, one of the province that has several interesting characteristic for the climate. Here is a joint work with people from another discipline. Gunardi and Henry is from statistics. This is from optimization concept. This is Mulyono Sabto is from agriculture faculty, and this one is for geographical faculty. This is the outline of my presentation. First of all, I will share the climate change issues in Indonesia, which is interesting. What is the topic which is interesting for us to do for the research? And the second one, I will show the problem formulation and methodology. And the next, I will share about the analysis using Bayesian change point for some stations. This that means the rainfall station. And the next, I will share about the dominant pattern by AOF and the rainfall map based on AOF in the DIY province, and then we will close with our future research. Okay, what is the climate change issues in Indonesia? As an agricultural country, there are some facts due to the climate change issues in Indonesia, especially the weather anomalies. For example, this month or this couple of months. In Indonesia should be dry season, but sometimes we have heavy rain, and then for a couple of days. So there are some cases of flooding or something like that in the dry period. So in here we have an anomaly of the rainfall pattern. That is the duration of the wet and dry season are said to be changed. The dry in we call this the dry in wet season and wet in dry season. Okay, the second problem is that the traditional cropping calendar, which has been usually used by the farmers in the country, it seems no longer valid because of this anomaly of the dry and wet season. The traditional cropping calendar has a big problem in here. Okay, what is the impact of the weather anomalies? One of them is, the first one is the major threats of the sustainability of food security, health, and some other field. The second one, the phenomena can trigger some disasters such as drought, flooding, crop-based attack, and etc. And this affect the decreasing of the main food production such as rice, corn, and wheat. Rice is the main food of the people in most Southeast Asia. Okay, it is reported that the climate change decreases the Indonesian rice crop production into more than 10%, or between 50,000 to 150,000 tons per year. So it is the big problem for the people who has the main food is from rice. Here. Okay, what is the fact of the in the DIY province? This is in this area there are some critical soil. Yeah. In this type of soil, the cropping in this area depend only on the rainfall. It is impossible for us to build the irrigation system in this area. And the next we have two facts from the empirical study that there are two or more areas which are so close to each other, but they have the different rainfall pattern. Yeah, this is the problem. Why this can be happen in this area? Okay, this is the situation. This is in wet season. We have a green area, but in the rocky sides and in the highland. In here we have some fountain here, and also there are some reservoir, which is in the wet season. But in the dry season we have this one. There's some drought in this area. This one is one of the reservoir in that place, which is in dry period, in dry season. And this one is the crop area, the farmland for the green one in here, For the dry season, it is the condition is like this. So, by this area, it is impossible for us to build the irrigation system. It is the cropping in this area depend only on the rainfall. It's the cost is very high to build the irrigation in this area. So there's the problem. Okay, what will we do in our research? We will study the rainfall pattern. The goal is to do some updates of the traditional public calendar, and the method that we use is the Bayesian change point in combination with empirical orthogonal function. The data comes from the Agency of Meteorology, Climatology, and Geophysics of Indonesia. Yeah, the BCP is used to detect the change point of the rainfall pattern, and the second method, that is AOF, is used to study the dominant pattern of the rainfall in such area. Okay, this is the combination between BCP and AOF. Yeah. By BCP, we have the shifting seasonal period of the rainfall can be detected. Yeah. And also the behavior change of the rainfall in some sample stations can be detected and compared by the original rainfall. And by the AOF, we will study the dominant pattern of the rainfall. The BCP is based on the famous method, which is Markov-Chain Monte Carlo, or MCMC, to estimate the change point of the rainfall based on data parameter. Okay, in here I will show the behavior on two stations. The first column in here, the third column in here, shows our traditional public calendar. This is the different pattern. This is high rainfall, this is sparse rainfall, and this is rainfall, and this is dry, and so on. But current condition is like this. This is the change of the pattern of the rainfall in here. We have the dry period is longer than the original one. Yeah, and so this is like a stretch period of the dry period, and so on. And here the two stations is in a very close location. Is the distance from this location is about around 10 kilometers, but in the quite dissimilar landscape there are no mountains between this place, but we see that the rainfall pattern is different each other in here. We compute in what we compute in here is the based on the rainfall probability for the intensity more or the same as 8 millimeter per day. Okay, this is the other stations, which is in one of the regency of DIY in Gunung Kidul. This is the Purwasari, Palian, Purwasari, and Sabtosari. This is three closer area also. And this one, we see that there are some change point in here, some different change of the behavior of the rainfall from this area. Okay, this is the AOF plot. In here, if we see 1 point means 1 month. The rainfall in the accumulation of the rainfall in 1 month. So we have the point in the higher level and the point in the low level. The point in the low level means the drought, means the dry period of the month. The month who has the many dry period. In here we have the dry period. Is around 5 months and so on. This is in Gunung Kidul area. We compute from the 18 stations in Gunung Kidul. Yeah, this is the yearly dry period in Gunung Kidul started from May till October. But the dry level was different every year. The extreme dry season in long period happened from June 2002 and October 2002 in here. And also from April 2004 and to October in 2004 around here. This is the extreme dry period. And so we will study about the period of the long dry period is from here is around every 2 or 3 years. Okay. From from the graph, we can conclude that this area has a long delay period except in 2005 and back to normal cycle in 2008 to 2011. This is another area which is Bantul. In DIY province, there are 4 areas which is more cropping land is there, and so we consider in this 4 area. We have in the Bantul Regency has 12 stations, and we compute using UF for the dominant pattern, and we have this type of the pattern. This is the most extreme rainfall was happened on December 2007 and to January 2008, and the second was happened in April 2008. The extreme rainfall in 2006 was expected as a fact of La Nina, which was happened in this year. Okay, this is the long dry period is in here, and this is we show in the other area of the river. Okay, and this is the in Sleman area, which is the rainfall is high. The rainfall rate is highest compared with the other regency, and from the AOF we can show the GIS map for the rainfall map based on AOF1 data from 70 stations. From the analysis, there are some indications that the rainfall pattern in some regency are already shifted, and we should adapt it from the cropping strategy. Here our result, and for the future result, we will study the weather index-based crop insurance based on our result, based on our data. We will continue our research to weather index-based crop insurance. And the brief introduction of this will be presented in session AG02 at 9:15 p.m. Okay, thank you for your attention.
Question, please. So here you use the EUF analysis for station data. So, and you concern most about the EUF1 mode. So how dominant the EUF1 mode?
Okay. EUF basically based on the data from several stations, and then we use matrix analysis and also agent value or something like that. The EUF1 means the as a mathematic point of view, because most of us is from mathematics, is the show the dominant characteristic of the data. It is based on the highest eigenvalue of the covariant matrix. The autocovariant matrix, we have highest eigenvalue, and the eigenvector of the covariant matrix is called EUF1.
How many percent of the EUF1 usually? Because you have contained several modes of EUF.
Yeah.
But how many percent of EUF1 for most of the case?
For the EUF 2, 3 or something like that, it is important to characterize the little bit different mode, but the most dominant pattern is from EUF1.
Yeah.
And then after, if we have a mode which is like if we check for the data is a little bit different, we should check the EUF2.
Okay.
But in here we just consider the EUF1 first.
Yeah.
But what is the dominant pattern of this area?
Okay, thank you. Any other questions, please? In that case, so thank you, Dr. Paya, for your talk.
Okay, thank you for your attention.